So you can see my screen, right? Okay. So here is the screen where we're gonna talk about the course. Please let me know if you have any questions. We are organizing the course the same way we organized it last year, which is a little bit different from the way we did previously.
Dennis, we're not seeing the screen. Your screen.
You're not seeing the screen?
The screen.
Can you see now?
Yes. Thank you.
Okay. Okay. Thank you. As I cannot see what I'm presenting, please let me know every time I'm thinking that's something that is not in your screen. Okay. Okay, so we are organizing the course in the same. First of all, let me present Daniel Santos, which is also I think it's present. Right? Daniel, are you there? Yes, right?
Yeah. Yeah, I'm here.
Yeah, Daniel will help me organizing the course. All the material in the course will be in the Moodle system. Most of you are familiarized already with the system, but if you have any questions, you can send an email to Daniel, and he can send you some tutorial about how Moodle system works and so on. If you have any questions about that, please send to Daniel, okay? So I was saying that we are organizing the course the same way as last year, which is a little bit different from the traditional way I used to teach. In the traditional way, we normally used to talk about reservoir simulation models before, in the first part of the course, what we call theory. And then we usually go to applications, which is the apply reservoir simulations in these activities that I was talking in the first part of the class. Okay? Last year, I inverted that, and I think the result was good. We are trying to do that again. So instead of talking about simulation first, and then you're going to wait until the middle of the semester to start working with the simulations, you're going to be able to start working on the simulations right away. Okay, so and you're going to start working in your seeing some classes about these applications before we understand fully what's inside the simulation. Of course, there is pros and cons of each of these orders, but this one I think was okay because first, you have more time to do your projects. And second, when I talk about the simulations, you're already working with the simulator, when you already know what is a history matching, a data simulation, what is a production uncertainties, integrations for Cyber 4D, and so on. So it's much more useful for you to, I think at least, but you're going to have your opinion at the end of the course, to know what's inside the simulator before you have at least a little bit of familiarity of the models. Okay, so we are going this way again this year, and so the classes are going to be in this order here, and we're going to follow more or less the same order that I was talking in the first part of the course, which is first Manuel will talk about reservoir characterization. So the question was asked at the end of the talk was about the model. So Manuel is going to talk a little bit about that. But of course, in our classes, is the reservoir simulation class, we are not building the models. Okay, we're going to give the models for you already. You're going to change the models, but not build the models. Otherwise, we don't have time to do everything in one semester. Okay, but Manuel we explain how we normally build these models. Okay, considering mainly the reservoir properties, which is his main area of research. And then Guilherme Avanci will talk about simulation models, how we put all the properties together and how we select the fidelity of the models. We'll talk a little bit about this even emulators, but the focus is to put all together the data in a simulation model, how we do this, how's the best way to do it. which is these two main talks. The first talks will be about the green part of the closed loop approach. Then we're gonna have one class about the data simulation for uncertainty reduction, which will be given by Célio. And he will concentrate mainly in the data from the wells. And then Alessandra would talk here about the seismic 4D, data simulation with seismic 4D, but as she was in vacation, her seminar will be in a little bit later, after the other seminars, but there is no problem in doing that. Célio will talk about the data simulation mainly concerned about the using well data, which is the most common, and then Alessandra will talk in class 8 about seismic 4D integration, okay? And in between, we're gonna have 3 seminars about the blue part, which will be first given by Vinicius Botek about selection of exploitation strategy. João will talk about the integration of wells and production facilities, how we're gonna do that. And Susana will gonna talk about uncertainties and risk analysis, okay? So green parts, red parts, and blue parts, 2 of the green, 2 of the red, and 3 of the blue parts. So we're gonna talk in details about this closed loop that I have shown in the first part of this class, okay? Then in class 9, we're gonna have a test about these applications here, questions about what was given in the seminars. And before I go into the second part here, starting next week, and it's wrong here, is 28th of, not August, of September. I'm gonna change here. 28th of September, I think there is a, let me check it. Design. Oh no, it used to be a better pointer here in the design of the word too, but that's okay. I don't know if you're gonna see my pointer, but I'm trying to do this. Danielle is saying the due dates. Oh, when is that? Danielle, let me check again.
It's 6th of October, the due date, and then I will, yeah.
Okay, this was wrong here, and my version was not corrected. So the 6th of October is the due date of the tutorial. 6th of this October, yeah. Which is the 3rd class. So you're gonna have a few weeks to do this tutorial. This tutorial is only 5% of the total weight of the total final grade you're gonna have, but it's very important for those. It's gonna be very easy for those who knows simulation already, but it's very important for those who are never been in simulation before, because it's a step-by-step procedure in how you can build a simulation model, run a simulation model, and change a simulation model to do extra runs, okay? So it's a tutorial given by CMG, and Anna is organizing that for you. I think, I don't know if Anna is here or she left after the talk.
I'm here. I'm here.
You're here. Yeah,
I will release the instructions today.
Ah, you're gonna release today. Okay, so Anna will release the instructions today using Moodle, and then you can start today if you want. It's a very organized tutorial made by CMG, where you're gonna learn, if you've never used simulation before, step by step how you construct a simulation model and how you run this model, make some changes, and so on. Okay, and you're gonna have 2 weeks to do that. I think it's enough because it's not very complex. And at the end of tutorial, we also have some additional things that we can implement, select a well, and so on. So Anna will give all the details about that for you by the Moodle system, or even today, because today we're gonna finish the class more or less 11. 11:15 at most. And then if you have time, maybe Anna, if you have time as well, you can explain a little bit about the tutorial. Otherwise, you're gonna check by Moodle, okay? Okay, after we see test one, then we go to classes related to numerical models. We're gonna go deep inside the simulation models and trying to understand what's inside the model. What are the parts of the simulation model that are more important? For example, the mathematical model, the equations that are there, how they are solved, how is a black oil model. We're going to see the difference between black oil model and other models and so on. And these details, how we're going to treat wells and so on, these details are going to be covered in test two. And I hope I can give you as much information I can give here in these three classes about this numerical part. It's not too much. There are a lot of details inside, but I think it's enough for you, at least if you've never seen simulation before, to understand how the simulation works and how, especially this model is the most simple. We have the black oil model, how it works. And of course, if I have time a little bit, I'll talk a little bit about compositional models and thermal models and so on, okay? And during all this time, you're gonna have a project where you're gonna work in a simulation model and try to develop one of the topics that I'm gonna talk soon here. And the presentations will be only in January. And the due dates are also in January, 5th of January. All the presentations and the reports will be delivered on January 5th, but the presentation will be divided in two groups because we don't have time to present everything in one time. Probably going to have 20 minutes to present each one. I still have to check the number of official people in the course. Probably next week, we're going to send you some details about this, how much time we're going to have to present and these things, because I think we have about 20 students, and 20 students will be in 2 days, 10 presentations by day. So we're going to check all these details. So depending on the number of students that are official in the course, and then probably at the end of next week, we're going to see. And we're going to have three type of possible tutors here in codes, but we're going to select tutors depending on the topic you select. We're going to have three. We're going to use Unison 1 model, which is this model here. Unison 1 is a very, it's an offshore field of Brazil called Namorado field. Based on the data of this field, we build a benchmark model in Unison, which is called Unison 1. And it's good to work in classes because it runs in 5 minutes. So it's very fast model to run. We can fuzz a lot of simulation and so on. So we're going to use these models for you. If you will have a thesis or dissertation based on simulation and you want to select a different models, please let me know as soon as possible. We can try to select a different project for you. But most of you, especially for those who are not very familiarized with the simulator, will use Unison 1 because it's a very easy model. It's much easier to run than the other models. But if you have any project with your advisor that you are using simulator and you want to use another model, please let me know as soon as possible. Then we're going to try to select a different project for you. But if you don't have any idea on how to do, then you're going to just select one of these three activities. Activity 1 is a field that we're going to implement a production strategy. We call field in the development phase. That's why it's D. So the main activity here will be the optimization of the number of wells and the position of wells and so on. So we're going to use a simulator to select the best production strategy for this type of field. If you are more interested in fields that are in the management phase, that we have to select how much you're gonna inject, when you're gonna stop injecting, operating the field, and so on. Then it's Unison 1M. And if you are more interested in the data simulation part, then you go into Unison 1H, which is more related to the data simulation. So we have a field of a few years of production with some data production. And then our main objective is to do a reduction of uncertainty properties based on the data simulation that you're going to learn mainly in the CELU seminar. Okay. So if you already have a thesis or dissertation related to one of these topics, you can select. If you don't have any idea about this, you can talk to Danielle or to me or even Anna or the others to understand a little bit more. And then, but is there a date, Danielle, for them to select the projects? I think it would be good for you to 1 week, right? Or more.
Yeah, we didn't define yet, but I don't know, maybe 1 week. I don't know.
Yeah, it would be good for you to select 1 week for us to organize ourselves, but at most 2 weeks would be, because when you finish the tutorial, you have to start working in your project. So if you can give us the topic in 1 week, it would be great. But if you want to decide and talk more, and then 2 weeks at most. So by 6th of October, we have all the projects. So then we can organize how many projects, how are the categories, how we're gonna select each tutor for each student, and so on. And then we are doing the project. You're gonna have about 2 months and a half, more or less 2 months, a little bit more than, no, it's 2 months, right? October, November, no, 3 months. We have gonna have 3 months, but as we have vacations of Christmas and so on, 2 months and a half to do the project, I think is enough. Of course, we are gonna explain that we will be not a perfect history matching procedure, a perfect optimization, but the main idea is not to do a perfect job in the optimization part and so on. The main idea is for you to learn how to use simulator, and then you can learn what you do right, what you didn't do so right, what suggestions you have after you go through the process and so on. We're going to talk about the project in 1 or 2 weeks in a small part of one of these seminars. But the most important thing for you now is to select one of these 3 topics. Okay. Let me check. Okay, then we have details here about the grades. The grades are divided here. About 5% is the tutorial. Test 1 is 25%. Test 2 is 30%. The project report is 20%, and the project presentation 20%. Okay. Also, the project report is not something very complex. It's just a report, and the main part we are going to talk about it as well. But the main part is to explain how you use reservoir simulation in the process. Okay. I think that's it. Our presentation. These things are just details about how we are organizing the presentations. Here are just some reference. I don't know if you have access to the library in the Department of Petroleum Engineering. If you don't have access, please let me know. I'll see what I can do. But we have several books there that you can use. They have more or less the same contents about the second part here, which is the numerical part. They explain how the reservoir simulation works. And about this first part here, probably each of these people here will bring you some literature that you can see, because there is no book that talks about all these topics all together. We have a lot of papers, a lot of things. So this probably Manuel, Avanci, Sérgio, and so on will bring you some papers that you can read about these topics. It's much more updated than any book about these topics, because this thing is changing every day. Okay. Do you have any questions about that?
Dennis,
Okay.
I'm afraid the dates for tests 1 and 2 from both tables are different.
Difference.
Test 1 and test 2.
Test 1 is here you say?
Yeah.
Which tables you're saying?
The first and the second table.
Okay, yeah, the first is more reliable because it's the second one I forgot to change some things. So test 1 here is 17th of November. I think this is not the correct version because I had corrected that already, but it's too wrong. 22/12 here. You're gonna have a very good Christmas here, right? Very close to Christmas. You're gonna have a simulation test, but there is no other way because we have to finish the course by this date here. The ideal thing would be to go a little bit more in January, so we could skip this class here and go to the part. I will see what I can do, but otherwise there is no class and there is no other week remaining to put this thing. So we have to have 15 classes, and I'm sorry, the test will happen very close to Christmas, but there is no other way. Okay. I think now is okay, right? And this, I think, is, yeah. These two are holidays. The 8th of December and 29th of December are holidays. That's why I had these things here. So they're only the classes that we are not having are these two. And we have to finish the course by 12th of January. Okay. Any other questions or comments? Or anything? Okay. If there is no other comment, I'll start. I'll have a problem because now I was planning to give another part of the first part of the course, but I have to finish. The plan is every week to start at 8 and finish at 11. Okay. And then you can have this extra hour to work on the tutorial, on the projects. You can have take questions about all these things, the project, and so on. And today I was planning to finish 11, so I'll try to finish. So I have some slides here that I'll give to you, but they're just general slides about the reservoir simulation. I will put it, I'll make it available for you in Moodle, and I'll and answer any question that you might have if you have questions about these slides. But I will talk everything about these slides again when I start the second part of the course. Okay, so don't bother if you don't understand them fully. I was talking. Can you see the slides?
Yes.
Yeah.
Yes. Okay. So I was talking about two parts here. One is mostly about the introduction aspects of the simulation, and the second part was based on the applications we had in the model base. So this, I will not talk about this part too. The slides are ready. I will put in Moodle, but we are going to talk, we're going to see these details in the seminars of Manuel and Avanci and Celio and so on. And just a second. Change here. So just take my camera and put this to try to see the okay. And I'll talk very briefly in 15-20 minutes about this part 1 here. Okay. So I'm sorry these slides are in Portuguese, but I didn't know that some of you didn't talk Portuguese. They speak all Portuguese, so the slides are in Portuguese. So don't bother again for you two that don't speak Portuguese. I'll do the best I can to say this in English, but you are gonna see this again in the course in the next class. Okay. So what I'm saying here is that simulation models are mainly used for these two types of things. First one is forecast production. which is here, and second is the decision analysis. And these two main things are the things that we are going to focus in the class, right? There are three main activities that we are going to focus in the class: the forecast production, including uncertainties, the decision analysis based on models, and also how to improve these models, which is the red part, history match and data simulation. So these are the three main things that we are going to see in the class. And in order to build these simulation models to do these things, first of all, we need to represent these complex geometries that we observe in real reservoir. Like we have faults, we have fractures, we have complex geometry, heterogeneities, especially these carbonate reservoir fields that we have in the pre-salt, and even in other countries that you may have observed before. They are very complex, and we have to represent these in numerical models. We are going to learn how to do that in this course. Okay. Another thing that's very complex, sometimes not so complex when we have, for example, water injection, but other times we have a vapor injection, we have a polymer injection, we have WAG, CO2 injection, and so on. Sometimes they're very, very complex recovery mechanisms that we have to put this. So the main things that we're going to see in the course is to see how to use simulation for these complex geometries and this complex process, and what are the main limitations of the reservoir simulations in order to do that. So when I start talking about these limitations, we're going to see that the limitations are very important. Sometimes the models are very different reality from the real models. For example, the real models are in the porous media, which has a dimension of a micropores here. But the simulation models sometimes have blocks, numerical solution that are hundreds of meters. So this is a very main limitation. So we have numerical errors in our models. We have discretization problems and scale problems that, but not they are not full barriers for using the simulation models in our real day-to-day life. Okay, so although we have these numerical limitations, we're gonna see, and these others that I'm gonna talk about, we're gonna see that we can use these numerical models. And industry use these numerical models very often to take decisions into forecast production and so on. So we have limitations here, but we are gonna learn in the course how to overcome these limitations, okay? So the numerical errors are probably the main limitations we have today because of the size of the computers we have and because of the time we need to run this, the memory of the computers and so on. We have to use nowadays models that are very different, have a scale that are very different from the scale where the physical mean that we are running the petroleum in the reservoirs, okay? The second main limitation here is the uncertainties, as we're going to observe in the seminars and in even in theoretical part. We have a lot of uncertainties. The reservoirs today are much better than the past. We have seismic information, we have well tests, we have a lot of information, but it's still, even with all this information, we have a lot of uncertainties in the reservoirs today. And because of these uncertainties, we have to work with these probabilistic approaches, multiple scenarios, and so on. And in order to do that, we have to represent the reservoirs even faster, because instead of running one model, normally we run hundreds of models or even more. Okay, so numerical errors is the main limitation. Uncertainty is the second main limitation. Another limitation that we're gonna see is the representation of fluids, because the petroleum fluid is very complex, and even especially if you're gonna have injection of gas, injection of CO2 in these carbonate reservoirs, we have to treat the fluid very carefully. But most of the simulations, we have to simplify a little bit the fluids in order to do, and even if you don't simplify, the representation of these fluids is not so perfect. So we have some errors that comes from this main limitation of fluids, okay? And the mathematical equations that represent the physical process is another main limitation that we have. We're gonna check that, of course, we can include as much as physical behavior as we can in the mathematical equation, but we have some limitation. There are several things that can happen in real life that are not in the equations. So if this happens, we also have an error there. And a fifth category of the limitation that conclude the main limitation that we have in the simulation models is the way we represent wells and how integration with production facilities. Okay, so keep in mind throughout the course and even after the course that we have all these limitations. Okay, and this is the main idea. We're gonna talk again when I go into the theoretical part of the simulations. We're gonna go again about these topics here, and it's very important for you to understand in the first part of the course when we talk about building models and using models in data simulation, when they are using models for optimization procedure and so on, that we are dealing with models that are not perfect, okay? So don't trust 100% in the simulation models, but learn how to understand the effect of these limitations and how to use these limitations in your procedures you are concerned. So you have a project concerning data simulation, you use these limitations in one way. If you have a project related to optimization of production facility, production also, and so on. So we are going to talk more about these limitations, but from the class 1, be very concerned about this limitation and be careful when you use simulation because of these limitations here. But of course, even having these limitations, we are going to learn how to overcome this and use data to try to improve our models to have at least an average behavior of the simulation that are useful for us for the activities we are talking about, okay? So the main objective of our course in the simulation is to predict, forecast the behavior of the reservoir. And doing this, I can also have other objectives like maximizing objective function, maximizing oil production, or NPV, or minimizing risk, and so on. So we have this, can use this main objective. In order to do that, we are going to write a computer program that tries to mimic the behavior of the reservoir using these equations. So we go from the physical model to the mathematical model. Here in the physical model, we have to understand the equations that are the most important equations for the physical aspects that are responsible for the fluid movement of the petroleum in the reservoir. Then we try to represent this mathematically, go into this numerical model because mainly because the geometry is too much complex to solve this analytical. We go to numerical models. So in this numerical model, we build these tools that are simulations, that are computational programs that try to represent the behavior of the wells. Okay. So what we are learning in the course is how to build these models here, as the one I'm showing here in the left. Each model here will be a model that tries to represent these mathematical equations that rules the physical behavior of the fluid in the reservoir. And of course, each of these blocks here, which is here, we're going to work here to understand how we use the mathematical equations to solve this flux behavior in the well. Okay, so each of these blocks will have a fluid coming in, fluid coming out from the surface, or even from the wells here if they're here. Once I have the boundary conditions that sometimes are the boundary conditions for the reservoir here, because the reservoir is no flow boundary conditions or a fracture here, for example. or even a boundary condition, which is a well here, that's taking fluid out of the block or putting fluid in the block. We're going to learn how to use these mathematical equations to write how the equations and how much the flux is coming in, out, and accumulating in the blocks here, which is being governed by Darcy's law, which is you have seen in Reservoir 1 or even in other courses in our classes. And if you are not familiar with reservoir engineering, please let Danielle know as well, because then we can give you some additional material for you to read about this. What is reservoir engineering? What are the equations that are running here? We are not going into detail in the equations, so it's very important for you, if you're not familiar with that, to go into the equations. Okay. So here we put all the knowledge we have in engineering, math, physics, numerical analysis, thermodynamics, geoscience, and so on. And this simulation is a very multidisciplinary task. Of course, in the course, we are not learning about all this. We are going to simplify a lot the numerical parts. We're going to try to give you in one semester what is enough for you to be a good simulation user. Of course, this course is not enough for you to build a simulation because there are a lot of details there. We normally have a second course of reservoir simulation, more advanced for those who want to build a simulator. But as we are not having this course lately, we are concentrating, try to give in this simulation one how to be a very good user of reservoir simulations. Okay. So this I can jump. So the equations basic we are running is conservation of mass in these blocks that I showed in the previous slides. Once I go to this conservation of mass and understand the fluid behavior, which can be a very simple equation if you are using a simplified model like a black oil that we're going to talk about, or sometimes we have a more complex behavior, you have to use thermodynamics and so on. So once we have the conservation of mass and understand the fluid behavior, we go into Darcy's law, and this will be we go into these equations here, and we write the mathematical equations that are governing the flux into the reservoir. Okay, so I will talk very much more about this in the second part of the course. Here's just an introduction. Once we have the reservoir, we're going to put the grids in the reservoir, and once we have these blocks, we're going to study how much mass is coming in right of the blocks. For if I put a well here, injector and producer here, we're going to learn in the course how to model this flux in the reservoir. In order to do that, we write the physical process. We go into the equations, which are equations that normally are very complex equations. So we have to discretize them in complex geometry. We have to discretize the equations and go in these equations that we can solve. Put the boundary conditions here that are boundary conditions of the reservoir, initial conditions, or the wells, and so on. And once we have these equations, we have the boundary conditions and the mathematical, we go into the process of simulation. So again, we are not giving too much details about this because the objective of this course is not to write a simulator or to build a simulator. It's just for you to understand which equations are there and the limitation of these equations. So the most important thing here is for us to understand the limitations of these simulations. Okay. Here I give several examples, but this is a typical example of a reservoir simulation where we model, where we have these blocks, and here they have the wells and the boundaries, the fractures, and so on. And once we have this model built, first we're gonna learn with Manuel and Avance how to build the models. We're gonna learn with Celio how to calibrate these models, because as we're gonna see, the models are not perfect. They have all these limitations, but if they can honor the past, they have a good chance to be useful in the future. So we're gonna learn with Celio and Alessandra how to improve the quality of the model using the past data. And then we're gonna learn a little bit with Vinicius and João and Susana how to use this model in order to forecast production and take decisions, okay? So let me check here. One thing that before we finish is that there are several types of simulation models. And this type, we're going to learn how to select the best models here. But of course, the selection of the models is a function of what we're going to work on. So if we have a black oil reservoir, oil with a high density and so on, we can use a model called black oil. And this has a very important advantage of it's much faster. Because instead of simulating each component of the petroleum, we are separating this in only 3 components. One is water, the other gas, the other oil. And then the equations are much simpler to solve and much faster to solve. And we can use, for example, this. But of course, we cannot use a black oil model in a case where I'm injecting CO2 with gas in a light oil reservoir, and we're going to have a very complex behavior of the fluid. Then black oil is a simplification that's not enough to simulate the results. So the first thing that we have to learn is to understand the fluid we have in the reservoir, the fluid we're going to inject, and select the type of reservoir simulation we're going to use for that. So we have number of phases, number of components, and we're going to learn how to select this and how the equations will be impacted by this selection, okay? Another important selection we are going to learn in the classes is by the type of rock we have. If it's a conventional simulation, we can use only a matrix, and the flux, it's a 4 flux in porous media. But in some reservoirs, we have special fractures, we have bugs and karsts and so on. So we may have models that are more sophisticated. They have dual porosity or dual permeability and so on. So the second selection here that we have to learn is the type of rock we're going to simulate and the selection of conventional dual porosity and permeability, okay? And then we're going to select the process that's more or less related to this one. The fluid is in the reservoir, but also the process. If we're going to have inject vapor with different temperature, with different type of polymers or CO2 and so on, we have several chemicals that can inject. Or sometimes we have some process that water gunning or gas gunning is very important and so on. Based on these categories here, we're going to select the models, okay? Then we have to select the best way, how we can represent using the grids. There are several types of grids. We're going to talk about this in the course as well. The number of layers we're going to have and the blocks, because we have a limitation in the number of simulations in order to have simulation that runs in a reasonable time. So we have to select the layers and so on. So in the course, we're going to give you some hints on how to select the grid, how to select the layers and the number of blocks. Then we go into the numerical parts of the reservoir. We can solve the equations in a simpler way, or in a faster way, and so on. We have several methods to do that. One of the methods are fully listed. We solve all the equations at the same time. The other methods are a little bit more simpler, but they have some limitations and so on. So we're going to talk a little bit about these limitations here in this selection. Then how we're going to represent the aquifer, if we have an aquifer in the reservoir, and how we're going to represent the wells. So considering all these aspects, we're going to talk a little bit about this in the second part of the course. I hope after these classes, you're going to be able to select the best model you can for the process you're going to model, the reservoir you have, and representing the best way in the grid, the geometry you have, with the number of blocks that are available and so on, and represent the well in the best way and so on. So I will talk again about all these details here. Here is just a brief limitation about this thing, okay? Let me check now. The most important thing here, let me go here just to stop. The most important thing that we're going to talk here is that, of course, we are building simulation models for a reservoir that have kilometers of distance here, blocks that sometimes are kilometers, I don't say, but if blocks have maybe hundreds of meters here, or even at least 50 meters by meters in the Z direction here, we have information that well tests and so on that sometimes has one scale, information of seismic that has another scale. We have logs that have another scale and so on. We have pieces of the reservoir, testemunho in Portuguese is, forgot the word now, but a piece of the reservoir that in centimeters. But at the end, we have to simulate the porous media, okay? So we're gonna integrate all these different scales here in order to into our model. And this is one of the main limitations. We're gonna learn a little bit about how to overcome these limitations in the process. Okay? Let me just see if there is another important thing that I didn't say, because other things I will say. I have some slides here in order to, if we had time to talk about these models and these things, but I will do this, all the things again when I go back after test one, okay? So for today's classes, this is just an introduction, just to show what you're gonna see in the class, what are the main things that we're gonna learn in the class. So the main things we're gonna learn is how to use reservoir simulation models in this model-based decision and forecast, how to build the models, how to build the models in a fidelity that we can use in these processes, how to calibrate these models using data simulation. And at the end of the course, we're going to learn what's inside the models and what are the main limitations of these models in order for us to at least to choose the correct model for each problem that we have. Okay. I don't know if there is any questions in class, but these slides are, I'm going to put in the Moodle system. Don't bother if you don't understand everything, because we are going to see all details about these slides in the next classes, okay? And I think that's it for today. If you have any questions. Okay. If you don't have any questions, anything, remember to, first of all, to check Moodle today about how to do the tutorial that Anna will made available there. If you have any questions about the course or the selection of the project or so on, please let Danielle know by Moodle as well. I'll be in contact with Danielle for that. And if you having no idea about what project to do, try to describe to Danielle the best, what you like more, what's your thesis and so on. We are trying to select one of the projects for you. And I think that's it. And if you have any questions, you can, all the communication of the courses, it's preferable to do it by Moodle instead of email, because it gets organized there, all the classes there, all the material is there, and anything. I think it's better to do through the Moodle system, okay? If you don't have any questions, I hope you have more questions in the next classes, because today almost there was any more. But if you want to do questions in the classes in Portuguese, please do in Portuguese. There is no problem as well, okay? Okay, so no questions. See you next week. Next week will be a seminar of Manuel, but I will be joining also at least in the beginning to give. If you have any questions about this first class, we can take in the beginning of the next class. Okay. Thank you all for the attention, and thank you, Danielle and Ana, for being present. I think Gonzalo was also there. See you next week.